So I was talking like 5 modes of NBMA on the other day. The NBMA stands for non-broadcast multi-access.
Yeah.
Now in non-broadcast multi-access, we have 5 modes, meaning based on the mode that you pick, the OSPF behavior, the OSPF policy will be different. You can, in another word, say 5 different OSPF policies or 5 policy types in OSPF. Those 5 types we learned through NBMA, but if you want it to be applied in a point-to-point or in an Ethernet environment, you can enable. But it is mainly for NBMA. But because there is no NBMA in the real world, we don't have that old extra to 5 frame relay, ATM. These are all very old technologies. So you don't have that NBMA. Then why are we learning? We are learning so that 5 modes that you have in NBMA is 5 different OSPF policies. And you may be willing to have one of the policy in your organization. For that, we need to learn. Right? So,
Yeah.
let us see the 5 modes theoretically today. And then practically tomorrow, I'll be building the frame relay environment for you, and I'll be demonstrating. So these 5 modes are as follows. Number 1, non-broadcast.
Yeah.
Number 2, point to multi-point. 3, point to multi-point non-broadcast. 4, broadcast. 5, point to point. Right. So now there are 5 modes. There are 5 modes that NBMA has got. One is non-broadcast, as we saw. Now, what is the special of this? This is the default mode. Default mode. In a frame relay environment, on the frame relay enabled port, when you enable OSPF, it will show network type as non-broadcast. You remember on the other day when I was doing lab, I was showing you network type as broadcast and point-to-point. But in the frame relay enabled interface, when you go and check, by default, it is going to be non-broadcast.
So frame relay enabled interface means like
by
it is an attribute
default,
of
I
an
told
interface,
you
right?
on
Frame
serial
relay.
interface, the default
So interface will be
encapsulation
sending
protocol
those
is HD. You remember? HDLC, PPP, and PPP.
No, sorry, I forgot. HDLC, okay.
Instead of HDLC, if you have frame relay, that is not by default. You need to configure. On Cisco router, the serial interface by default will have HDLC. The non-Cisco routers will have PPP, point-to-point protocol. But if you go and say frame relay, if you will go and say frame relay, and then enable interface on that frame relay, then enable OSPF on that frame relay interface, then it will be non-broadcast. The network type will be non-broadcast. Network type non-broadcast. What is special in that? I told you it is default. Second one is neighbors are not dynamically discovered. Usually, the neighbors are dynamically discovered. No, when you enable OSPF, they send the hello packet and they learn the neighbor. Not yes or no, please, sorry. When the hello packets are sent, they discover neighbor dynamically, right? Two routers discover neighbor dynamic. Did you configure neighbor address
Sorry.
and say go and talk to this neighbor? We never configure neighbor address. We usually say network only. It will send a hello packet and discover the neighbor. Remember the init state, two-way state. It learns the
No,
neighbor,
not.
dynamically discovers the neighbor and shares the DBD. It forms the neighbor, isn't it? But when you say when it is non-broadcast, when it is non-broadcast,
7 state.
the neighbors are not dynamically discovered, which means you have to manually configure the neighbor. You have to manually configure the neighbor. So let's say in a broadcast environment, what is broadcast environment? Normal Ethernet environment, isn't it? In the normal Ethernet environment, if you don't like dynamic discovery of neighbor, you can go and say the interface type as
Because only one broadcast domain.
You understand why we are learning this? Even though there is no NBMA mode needed, because we don't have frame relay. We don't have the old technologies, X.25 or ATM. Then why are you learning this? So that if you want this behavior in an Ethernet environment or in a point-to-point environment, if you want this policy, this behavior of OSPF, then you can use this modes. It will work even in Ethernet mode. When you go and change the mode as non-broadcast, what is the default mode on Ethernet environment? Broadcast. If you go to the interface of Ethernet and say IP OSPF network type non-broadcast, the neighbor will not form. If that is your expectation, if that is your policy, if you want the neighbor to be statically configured, then you need to know this mode. That's why you are learning. Now, if you have non-broadcast mode, the timers are not the usual. What is the usual hello timer and dead timer in OSPF? Exactly. Here it is going to be 30-second hello and 120-second dead timer.
Not broadcast.
You see? Here also 4 times. 4 times of 30 is? Yeah. Right? So 30-second and 120
and 40 seconds.
That's the hello time and dead time. Next.
Timed out. Okay. That's dead time.
The neighbors all should be in same subnet, same broadcast domain, same subnet. Meaning you cannot have one neighbor in 20 network and another neighbor in 30 network. They all should be in same network. And then there will be DR and BDR election. There will be DR and BDR election. At last, because you are having DR and BDR election, it is well suitable if you have full mesh. Mesh. It is well suitable for full mesh. Now you see, is this full mesh? No. So if you don't have full mesh, then you are not supposed to use this mode. Why? What is the problem?
Yeah.
You see, let's say this is a DR and this is a BDR, because I told there will be a DR BDR election, and this all will be other, isn't it?
No.
Now if the hub goes down, all the connection will go down. What will happen now? This also will become DR, this also will become DR, this also will become DR. What is the use of the DR BDR election? No use, isn't it? Because there is no connection between these three routes. They were all connected only through DR.
Other, yeah.
Yeah. Only in full mesh. So we understood when we should use non-broadcast. The next mode is
Yeah.
point to multi-point. You see?
Yes.
Point to multi-point.
DR. That's
And
why,
if you see, these two are RFC standard, meaning all
in full mesh
vendors
only we can
know this mode.
use this mode, right?
But these three are only in Cisco. Now let us go to the RFC mode, second one. Point to multi-point. Point to multi-point. For this mode, neighbors are dynamically discovered. Okay. So in the previous one, neighbors were not dynamically discovered. For this mode, neighbors are dynamically discovered. Next, the timers are same, 30 and 120. And then the difference is no DR BDR. No DR BDR. And the timers are this, neighbors are dynamically discovered. Because there is no DR BDR, it can fit in any topology.
Yeah.
It can even fit in hub and spoke, isn't it? Because there is no DR BDR. Any topology.
120.
And all should be in same subnet. All neighbors, same as usual.
That means kind of point to point. Oh, okay, it's a point to multi-point, right? Okay. Oh, BDR.
Right. So we have seen non-broadcast and point to multi-point. This two are Cisco. Let us now go to the third method, which is a mixer of first two. You see the name also, you see, point to multi-point, which is second one, non-broadcast, which is first one. You got it? So this third one is a mixer of the first two. Now, this is called point. Any topology, because there is no DR BDR. Whenever you don't want DR BDR, and you want the neighbor to be dynamically discovered, you know.
First
But
one.
see, it's a
Yeah.
multi-point. Usually, no DRBDR is in point-to-point, isn't it? No DRBDR is in point-to-point. But now it is a
Sir,
multi-point.
so point
In
to
a multi-point
multi-point,
environment, if you don't want a
when to
DRBDR
use in
and you don't, you want the neighbor to be dynamically
open hub
discovered,
that method.
then you need this point-to-multi-point type.
Okay. I mean, yes, yes. But why to
Fine.
use like in some topology if you don't want DR and
Point-to-multi-point
BDR selection?
non-broadcast.
So
The mixture of both, I said, meaning the best of both. What is the best thing, you know? The first one.
so this is
The
just
first
like a
one, if
neighborship
I
it will
say this is
establish
the best
and
thing, you will not, you
so
may
this
not accept initially. In the first one, what is best to know? Neighbors are statically
yeah,
configured.
point to point, yes.
That is how you feel.
Got it.
See, in a cloud like this, frame relay or something, you want to form neighbor. If the neighbors are dynamically discovered, then you will not feel comfortable. What if a wrong guy, a bad guy, forms neighbor by sending hello packet? You don't like. What is more secure? When you say this B is your neighbor, you go here and say B is your neighbor. You go here and say A is your neighbor. Then there is a security. You agree? That is why in such environment where you see less security, where you see security issues, you will like this one. Yes or no?
Yeah.
Yeah. So point to multipoint non-broadcast, neighbors are manually configured. Next. Secondly, the best of second one. What is the best of second one? The second mode. Very good. So it can fit in any environment, any topology. No DR and BDR. Right. No DR, BDR. And the timers are same, 30 and 120. And then same subnet. Okay. Did you understand these three differences?
Yes.
First one is neighbors are manually configured. There will be DR, BDR. Only recommended for full mesh. And timers are 30 and 120. Second one is no DR, BDR.
Best of this one, no?
Neighbors are dynamically discovered.
Because there is no DR and
any
BDR.
Topology. Third one is any topology because there is no DR, BDR, but neighbors are manually configured. You understood? Now the fourth one is same like broadcast and point-to-point. But in NBMA only it will be useful. See, you don't need this one. In NBMA means what? Non-broadcast multi-access. You will see the first one is default. No, the first one is default. But if you wish to have
manually configured, that's why no DR and BDR. Yes.
Go on, say. Then it will behave like a broadcast. In a broadcast, will neighbors are dynamically discovered. In a broadcast, normal Ethernet. Yeah. So neighbors are dynamically discovered. Timer is 10 and 40. And DR, BDR, election. Yeah. No, it's not normal thing. In NBMA, if you want this normal thing, see, we don't have NBMA. You will not need this. Next is point-to-point.
Yeah.
Point-to-point, let's say in NBMA only this is needed. Again, I'm telling you. You have this one in 1020 network, this one in 10 network, different subnet. So you need to have one point-to-point here, another point-to-point here.
Yeah.
But inside what? You have frame relay. So in the frame relay environment, if you want to have point to point, when you want point to point, when you have multiple subnets, then you need to enable point to point. Will there be a DRBD
Yeah.
election? No. In
Neighbors
point
are
to point, there
dynamic
is no DRBD. What is the timer?
dynamic
10 and 40.
discovery.
Yes.
Mm-hmm.
So in a non-broadcast environment, if you
40.
want an
Mm-hmm.
ordinary broadcast, ordinary point to point,
This
then
is
you go
normal
with
thing, no?
this
Mm-hmm.
two modes. Right, but it won't be needed because we don't have
Okay. Okay.
non-broadcast. But tomorrow I'm going to simulate that
Yes.
old
Yes.
technology non-broadcast and then show you all this five.
Mm-hmm.
Okay. So let's start.
Mm-hmm. 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 Yeah. Oh no. Point to point. Yeah. Yeah. 10 and 40. Mm-hmm. Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Yeah.